Hello, everyone, and welcome back to Ooh. Sorry, I think I may have been echoing there for a second because I had both mics on. Hello, everyone, and welcome back to Teach Astronomy. My name's Victoria, but you can call me Vicky. And today is Monday, so it is Bookstream Day. So today we are going to be reading Chapter 2 of Dreams of Other Worlds. It's all about Myrrh. The chapter title is Myrrh, the Little Rovers That Could. So that should be fun. I see somebody has a question in chat. When will the next Q&A session be? It will be on Wednesday. I should actually add that to the schedule right now. You know what? Thank you for reminding me. But it's going to be on Wednesday at 1 o'clock Arizona time, so noon for me. And it will be immediately after our astronomy news chat, which will be all about perseverance. So that's exciting. There it is. I'm just going to add that real quick so that I can point people to the right place because, always want to make sure I'm doing that. Have I lost? I have totally forgotten how to change did they move it? Okay, you know what? I will do it later because it seems as though it is on the schedule. Oh. Is it actually? Great. Then I was ahead of the game. Look at that. But yeah, so we are going to be, today we're going to be reading about Myrrh, which should be fun. This chapter is actually pretty beefy. This one's an extra 8 pages from last time. So we shall see if we can get through all of it in the regular 2 hours. And if not, we will figure it out. But it should be fun. And because it is so long, I think I'm just going to jump in and get started. I know there's not too many people here, but hopefully they will be able to catch up when they get here. All right. Myrrh, the Little Rovers That Could. The essay is short and very simple. The words are almost heartbreaking. Quote, I used to live in an orphanage. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for the spirit and the opportunity. End quote. Sophie Collis was abandoned at birth into a Siberian orphanage and brought by her adoptive parents to live in Scottsdale, Arizona. In 2003, at age 9, she was writing in response to a call from NASA for names for its upcoming Mars rovers. A team of judges selected by the Lego Company and the nonprofit Planetary Society painstakingly whittled 10,000 entries down to 33, and NASA made the final selection. Sophie unveiled the names at a pre-launch press conference hosted by Sean O'Keefe, NASA's administrator, who noted that her story twinned the 2 original spacefaring countries. It's safe to say her dreams are as boundless as space itself. 6 years later, in language that was formal, cumbersome, and numbingly prosaic relative to the lofty sentiment it conveyed, the U.S. House of Representatives gave a formal nod to these remarkable robotic emissaries with the following resolution, number 67 from the first session of the 111th session of Congress, adopted unanimously. This one's a long quote, so get ready. Whereas the Mars exploration rovers Spirit and Opportunity successfully landed on Mars on January 3rd, 2004, and January 24th, 2004, respectively, on missions to search for evidence indicating that Mars once held conditions hospitable to life. Whereas NASA's Jet Propulsion Laboratory, JPL, managed by the California Institute of Technology, Caltech, designed and built the rovers Spirit and Opportunity, whereas Cornell University led the development of advanced scientific instruments carried by the 2 rovers, and continues to play a leading role in the operation of the 2 rovers and the processing and analysis of the images and other data sent back to Earth. Whereas the rovers relayed over 250,000 images taken from the surface of Mars. Whereas studies conducted by the rovers have indicated that early Mars was characterized by impacts, explosive volcanoes, and subsurface water. Whereas each rover has discovered geological evidence of ancient Martian environments where habitable conditions may have existed. Whereas the rovers have explored over 21 kilometers of Martian terrain, climbed Martian hills, descended deep into large craters, survived dust storms, and endured 3 cold, dark Martian winters. And whereas Spirit and Opportunity will have passed 5 years of successful operation on the surface of Mars on January 3rd, 2009 and January 24th, 2009, respectively, far exceeding the original 90-day Mars mission requirement by a factor of 20, and are continuing their missions of surface exploration and scientific discovery. Now therefore be it resolved that the House of Representatives commends the engineers, scientists, and technicians of the Jet Propulsion Laboratory and Cornell University for their successful execution and continued operation of the Mars exploration rovers, Spirit and Opportunity, and recognizes the success and significant scientific contributions of NASA's Mars exploration rovers. That was a mouthful. Borderline, legalese there. Whew. My coffee's still too hot. Okay, we will just continue because that was the end of a section, but we'll keep going. Geographies of other worlds. By the late 20th century, Mars emerged as a familiar landscape we recognize and cherish. Unlike Mercury, Venus, or even our own moon, Mars has come into full relief. It is as if a Mercator's projection of Mars has lifted from its paper and rounded into a globe with tangible polar ice caps, soaring volcanoes, immense rift valleys, recognizable craters, and plains of crescent Balkan dunes. Our robotic partners have added these features of Martian terrain to the iconic landscapes that preoccupy and persist in the human imagination. Images sent back by Mariner, the Viking orbiters, Mars Global Surveyor, and Mars Reconnaissance Orbiter allow us to turn the globe of Mars in our hands, so to speak, and trace the planet's volcanoes, its broken and unzipped canyons, and its ancient and desiccated riverbeds. With the Mars exploration rovers Spirit and Opportunity, we've explored in fine detail Victoria, Gusev, and Endeavour craters, and captured our closest view yet of the Red Planet. Asked to name a landmark on the Moon, most people would probably answer the Sea of Tranquility, the landing site of Apollo 11. A few might mention the lunar Apennines, the landing site of Apollo 15. But ask most 5th graders about Olympus Mons, Tharsius Bulge, or Valles Mariners, and they not only readily reply, but also immediately envision these remarkable topographic features. With a fleet of NASA planetary missions perusing the solar system, by the late 20th century, near space emerged as a set of familiar landscapes. Serge Brunner comments that, quote, the deserts of Mars and the rings of Saturn are as familiar to us today as the most awe-inspiring landscapes of our own planet, end quote. Cultural geographer Dennis Cosgrove similarly has observed that the, quote, differentiated surfaces of the Moon, Mercury, and Mars are increasingly present to us, and have become a valid aesthetic to scientists and general audiences alike. As the planetary landscapes of our solar system settle into the imagination, Cosgrove explains that this terrain has evolved into places of, quote, detailed human understanding and care, end quote. He equates our familiarity with lunar or Martian panoramas or the surfaces of Saturnarian and Jovian moons with the crude maps and charted rocks that seafarers used to cross the open ocean. For the earliest mariners, horizon markers, if only for the forbidding and jagged edge of a dangerous coast, would have been a welcome sight. Waypoints indicating location and direction. Even a handful of recognizable land or sea features that made the seemingly blank and formidable marine expanse less threatening and more navigable. Passes and shorelines, mapped and remembered, altered our relation to the Earth's globe. The currently unfolding planetary geographies are again reconfiguring our sense of place, this time in relation to the solar system itself. Of all the planetary geographies beyond those of Earth, Mars's iconic features are perhaps the most familiar and deeply embedded. Viking 1's initial glimpses of a rock-strewn plain rising to a salmon-colored sky surprised and delighted us, as did the frost-covered rubble of Utopia Planitia, photographed by the Viking 2 lander. With its Arizona-like desert terrain and dust devils dancing lazily over seemingly endless rock fields, Mars has become a place we know, remember, and dream of exploring. Even now, teams of scientists practice working in Mars Mars analog environments, such as the Mars Society's Desert Reach Station in Utah, or the barren and desiccated salt pans of Chile's Atacama Desert. In a valley near the Atlas Mountains of Morocco, scientists are studying the landscape in preparation for ESA's ExoMars mission. Research at these sites is focused on developing new technologies necessary for exploring Mars with a geologist's hands and eyes. Until a mission manages to place astronauts on the Martian surface, we linger over coffee table volumes from which spill its alien terrain of jagged and scalloped craters, hanging canyons, and high clouds clinging to volcanic summits. Jim Bell's Postcards from Mars vividly illustrates why we are so captivated by the red planet. Multi-page panoramas tumble open to a sunset glimpsed by Spirit from the rim of Gustav Crater, and of Opportunity's sweeping view of Endurance Crater, with its angular dunes a meter in height. A day on Mars, or Martian Sol, is not so different from that on Earth, about 24 hours and 37 minutes. Like Earth, Mars has seasons due to its similar axial tilt, polar ice caps, and a year of 687 days. Bell, however, clarifies that while its landscape in appearance resembles Earth's desert terrain, atmospheric conditions on Mars are nothing like the world we inhabit. Having served as the landscape photographer and primary camera operator for the MER rovers, Bell was responsible for processing and interpreting images from Spirit and Opportunity's panoramic cameras, or PanCams. Of the Mars he has so patiently and tirelessly photographed and rendered, Bell writes, quote, "There's an I've seen that place before feel of looking out the window across a long drive in the desert somewhere. Rocks, hills, sky. It's all very Earth-like and comforting in a way. But it's an illusion. It's 30 to 50 degrees below zero. Degrees Celsius or degrees Fahrenheit, it doesn't matter. On average, out there. The air is almost entirely carbon dioxide, with only a trace of oxygen. And it hasn't rained in something like 2 to 3 billion years, if ever." End quote. Panoramas taken in the... There we go. Hi, Parzival. How you doing? For some reason, one of your messages got held because it caught the term ow, like OW. That's quite strange. I'm doing all right. Hope you guys are doing well. Panoramas taken by the rover's PanCams, specifically designed to capture Mars in spectacular detail, called for hundreds of photos to be carefully stitched together for a single panoramic view. Quote, "I wanted them to be postcards, views showcasing the beauty of the natural environment that we now found ourselves in," writes Bell. "We even set the first few mosaics up to be rectangular in shape, just like postcards." Photo composition requires proper interpretation with regard to color under Martian sunlit conditions and is driven by both aesthetic and scientific objectives. For instance, in the first image Spirit took of its landing site, Bell noted scuff marks in the Martian soil made by cables that retracted the lander's airbags. Quote, "The scratches looked very strange, though, like someone had taken a carpenter's plane and dragged it across the ground, so that pieces of soil were lifted and curled up like wood shavings. A place that at first glance seems commonplace turns out to be quite alien after all." End quote. Large, sweeping vistas taken by Spirit and Opportunity have afforded greater understanding of water deposition, erosion, as well as aeolian processes, and further demonstrate that Mars is a planet of ever-evolving geomorphology. When, for instance, the rover team wondered about the frequency of dust devils, Bell ordered the rovers to lie in wait and record what might pass the camera lens. Quote, "Within days, we started catching dust devils moving across the plains in the images. Over the course of months of occasional monitoring, we saw hundreds of them. As the plains got warmer with the advance of the seasons, it became clear that these mini-storms are a major way that dust gets moved around on Mars." End quote. Fortuitously, the dust devils happened to clean the rover's solar arrays, inadvertently extending their lives for years. Driving the rovers over broad stretches of terrain reminds us of the grave challenges of Martian exploration, for robotic or human explorers. During the fall of 2004, when the sun had shifted farther north and its light was less direct, Spirit was trekking as far as possible each day, depending on battery reserves. Bell recalls, quote, "When we drove or parked, we had to try to bask, lizard-like, with the panels tilted as much into the sun as possible to maximize our power supply." End quote. He recounts how the rover team targeted pre-selected lily pads on slopes that would catch the most sunlight. Late in 2005, while parked on Husband Hill, Spirit took some time away from its geological scrutiny to look upward and make a few astronomical observations. There, along with the rover, Bell recorded, quote, "curving star trails, potato-shaped moons moving in the night, shooting stars, the setting sun, and the rising earth as familiar yet alien and evocative." And it was detailed images of the Martian landscape sent back by the Viking orbiters and landers that enticed Steve Squires to become a planetary scientist. Principal investigator for the MER mission, Squires recounts how in 1977, as an undergraduate at Cornell University, he became entranced with Mars's stark terrain. He signed up for a graduate seminar to be taught by one of the Viking project scientists and ended up gaining access to the Mars Room in Clark Hall that housed the pictures streaming in from Viking. While some of the images have been collected into notebooks, the majority, Squires noted, quote, were on long rolls of photographic paper stacked on the floor or still in their shipping cartons, end quote. Looking to uncover in a matter of minutes some hook for a course assignment, Squires quickly became captivated by the alien landscape unfolding before him in photos that he realized even scientists had not yet digested. He found himself poring over image after image for the next 4 hours. Quote, "The planet that I saw in those pictures is a beautiful, terrible, desolate place," wrote Squires, who recalls stepping out of that room knowing exactly what I wanted to do with the rest of my life. End quote. Squires' journey to exploring Mars resulted in NASA's twin rovers, Spirit and Opportunity, that in turn have captivated the world's next generation of planetary scientists and explorers. And that's the end of that section. Let's see if my coffee is cooled off enough to drink. It's still pretty hot. Am I going to do it anyway? Oh, that's very hot. Okay. Hope everyone's doing well today on this Monday morning for me. I know it's various times in the day for you guys. Did anybody watch Perseverance landing? Let me know what you thought of it. It's been a rough day. Oh, I'm sorry, Parzival. Hopefully tomorrow's better. I feel that. It was an awesome landing, though. It was really exciting to watch. I watched the control room stream. It was really fun. All right. Decoding the red planet. As we saw in the last chapter, Mars seems dead to the orbiters that daily send back images of the surface. The atmosphere is tenuous. Ultraviolet radiation and cosmic rays scorch the soil, and it rarely gets above freezing even on the balmiest of summer days. It's unlikely any form of life could exist on the surface now, but Mars has not always been so inhospitable. NASA's strategy in searching for life in the solar system is to follow the water. And even if there's no surface water now, there was in the past. Each of the Mars exploration rovers, Spirit and Opportunity, was designed for just a 90-day mission. In the end, they have vastly exceeded expectations with their indomitable traverses of the forbidding Mars terrain. Think of them as twin robotic field geologists whose primary goal is to search for the signposts of water. The record of past water can be found in the rocks, minerals, and landforms on Mars, particularly those that could only have formed in the presence of water. Spirit and Opportunity were not designed to detect current or past life in the Martian soil, but they can do the detective work needed to say whether there have been stable bodies of water that could have supported life in the past. Surface rocks reveal evidence of previous water in the way that they formed, by processes like precipitation, evaporation, and sedimentation. They can also hold clues for the possibility that water currently exists under the surface. The rovers have helped scientists diagnose the history of the Martian climate, which is now thought to have been warmer and wetter 2 to 3 billion years ago. The twin robots are also trying to parse the different contributions of wind, water, plate tectonics, volcanism, and cratering to the sculpting of the surface. Spirit and Opportunity provide ground truth data for calibrating the orbiters that continue to do remote geology and scout for future landing sites. A final goal is to prepare the stage for future astronauts by understanding the unique challenges of the Martian environment. That's the end of the section. All right. Meet the rovers. Spirit and Opportunity are squat and sturdy, as large as golf carts and almost as tall as an adult. Each weighs 400 pounds. They have 6 wheels, each with its own independent motor. 4-wheel steering allows them to make tight turns and swerve or turn on a dime. The design is based on the rocker-bogie system of the previous Sojourner rover. The wheels can swivel in pairs and pivot vertically to maintain overall balance. The saddest thing that could happen to a very expensive rover millions of miles from home would be for it to tip over onto its side or back, wheels spinning uselessly. So Spirit and Opportunity have a suspension system that balances the load any time a wheel goes up or down. As a result, the bodies of the rovers experience half the range of motion of the wheels and legs. The rovers can tilt up to 45 degrees without overturning, but software is designed to sound the alarm any time the tilt exceeds 30 degrees. The wheels have cleats for gripping in soft sand and scrambling over rocks. Oh, perfect. Thank you for that. Student McLeod always coming in clutch. I was just about to show you guys a picture of the rover, and that is a beautiful one. Hold on one second. I'm going to pull that up. There she is. That's one of them. They look pretty similar, if not identical. I'll leave this picture up for a second while I read this next section. In case you had a mental image of a NASA engineer, cap turned sideways, slamming a joystick from left to right as the rover careens over the Martian dunes, the truth is a bit more sedate. The rovers have a top speed over smooth ground of 2 inches per second, or 1/10 of a mile per hour. But even at that speed, there's no danger of recklessness. Hazard avoidance software is used that makes each rover stop and evaluate its progress every couple of seconds, reducing the true speed to a glacial 1/50th mile per hour. On Earth, the rover might get overtaken by a snail. It's a beautiful little rover there. And then we can also look at a photo of Sojourner. There's the little guy. Let me zoom out a bit. There he is. Sojourner's so small. It gave you a Scottish vibe. That's funny. Let's go back to... I guess I could see it. Yeah. They're cool little rovers. Actually, I should pull up when we were talking about Perseverance the other day, before the launch or before the landing, we found a size comparison picture that was really interesting. So you can see how they that is very small. How they all look in comparison with each other, because they're all very different sizes, the rovers that we've sent to Mars, and this gives you a better example of kind of how big they are compared to a person. So that's Sojourner, the little guy, very small. This is Spirit and Opportunity, and that is Curiosity and now Perseverance. And those are 2 random people. I don't know who they are. They might be important. I don't know. I want a photo of Curiosity and Perseverance. There she is. Yeah, Curiosity and Perseverance, they look very slightly different because of some of the technology differences, because Perseverance has some new stuff. But they're essentially exactly the same. The same as, the twin Spirit and Opportunity kind of thing going on. But yeah. All right. Let's get back to it. What's your guys' favorite rover? If you have a favorite. Oh yeah, I can put the picture up again, the size comparison one. 1 second. I'll leave that up for a minute while I read the next section, actually. The body of the rovers is the warm electronics box, a tough outer layer designed to protect the computer, electronics, and batteries, the rover's brains and heart. These vital organs must be buffeted from the worst extremes of the Martian climate. Temperatures at the landing sites can plunge from a daytime high of 70 degrees Fahrenheit to a nighttime low of negative 150 degrees Fahrenheit, a range many times larger than we're accustomed to on Earth. Engineers use gold paint, heaters, and insulating aerogel to keep the rovers in a comfort zone. Within the warm electronic box, the brain of each rover is a computer that receives data from the scientific instruments and relays it to one of the Mars orbiters, and then to Earth. Spirit and Opportunity are exquisite machines, but they're far from state-of-the-art in terms of processing power and data transmission rate. Moore's Law, the near doubling of computational power every 18 months, marches on, but the hardware on the rovers had to be tested for the severe conditions of space and frozen long before launch. So each rover's brain has only 128 megabits of RAM, and the data rate to the orbiters is only 128 kilobits per second. That's the equivalent of a very low-end netbook, and only twice as fast as a dial-up modem. If you have an iPhone, it easily eclipses the computational capabilities of both rovers. And this book was written in 2010, I believe, so that's not even today's iPhone. I believe I actually don't know how much RAM Perseverance has. My computer has 16 gigabits of RAM, though, if you want some context there. The beating heart of the rovers is their solar panels. Mars receives half the intensity of sunlight that the Earth does, and it's a real challenge to gather enough energy to power the rover and its suite of instruments. Each rover can function on 140 watts, the equivalent of a standard light bulb. The deck of each rover is tilted with solar panels which charge batteries within the warm electronic box. As the Martian winter approaches, there's insufficient power for driving, so each rover navigates to a north-facing slope and hunkers down for the months in which the temperature remains below freezing. This imperative has always been greater for Spirit, which is much farther from the equator than Opportunity. Your favorite is Perseverance right now. The helicopter is also really cool. Yeah, they've got the little guy that went with what's it called, Ingenuity. That went with Perseverance. That'll be exciting to see when they launch that. I don't know how long that's going to take for them to actually fly that. I heard something about maybe in the summer, so they might be waiting till later to do that. But yeah, that'll be really exciting. And yeah, they do look huge. You don't realize it because like even Sojourner is like, it's small, but it's like it's the size of like a medium-sized dog. It's like not tiny. It's not like your little RC car sort of thing. And then the huge jump up to Spirit and Opportunity is, that thing's huge. Like, look at that. That's pretty much the size of a person. Like they said, it's a golf cart size. And then especially I think with Perseverance and Curiosity, like you think that this thing is a lot smaller than it is because there's no reference in these like in the CGI stuff that they do where it's like showing that they're putting it down on Mars and stuff, and it looks so tiny because there's nothing to compare it to, but it's like the size of a car. It's huge. Yeah, they are vehicles. Yeah, I think the rover thing definitely, yeah, you're right. It puts a different image in your head about like how big these things are. Um, yeah. All right. Outfitting the field geologists. If you were a field geologist, your most valuable asset would be your eyes. Geologists are trained to recognize rocks and minerals and crystals, using archetypal images in textbooks and samples in the lab. But hand-picked samples, viewed in isolation, can never prepare a geologist for the complexity and apparent chaos of a real landscape. Oh, and I have a figure for you guys. I'm going to finish this paragraph and then I'll show you. Rocks are sometimes layered and sometimes jumbled. Their color and texture can change according to light conditions and perspective, and each rock's story only makes sense in the light of the surrounding terrain. Experienced geologists must take all this in through their eyes. With little atmosphere on Mars to carry sound or smell, sight is the critical sense. And then I'm going to show you guys our first real figure from the book of the day. Can I zoom in at all? Okay, hold on. Ta-da. Oh, there's the zoom. Okay. So this is a view down into the Victoria crater by the Opportunity rover as part of its decade-long exploration of the Martian surface. The dunes are similar to those seen on Earth, sculpted by wind in the thin atmosphere and shifting from season to season. In 2011, Opportunity reached Endeavour Crater, some 14 miles across. It looks like, what's it called? It looks like some of the dunes that they have in northwestern Arizona. And like, I think maybe some of California looks like this too. But those massive sand dunes. Some people in Arizona like to dune buggy over them. Which, if you don't know what a dune buggy is, look it up. It's wild. I don't do that. Hi Pratik, how you doing? We are reading the second real chapter of Dreams of Other Worlds. So it's all about the first Mars rovers. So not the first ones, but the twin rovers. So Spirit and Opportunity. Oh, they do that in the UAE and Dubai. That's crazy. They are beautiful dunes. I like them a lot. It's crazy too, because you look at this picture, right? And you're like, oh, somebody took like a cool picture of some dunes somewhere in like, I don't know, the Sahara Desert or something, you know? Or like I said, like northwestern Arizona or UAE and Dubai or something like that, you know? Somewhere on Earth. And then you realize that this is from Mars. And it's very wild, you know? It's cool. All right. The rover's eyes sit at the top of a mast, roughly 5 feet off the ground. Twin CCD cameras are used to form stereo images. The cameras can rotate 360 degrees to make a complete panorama, and pivot out 18 degrees to scan the landscape or the sky. With 16 megapixels, they are similar to high-end digital cameras you could buy, and each one weighs 9 ounces and could fit in the palm of your hand. But unlike a commercial device, the rover cameras have a large set of color filters designed to help diagnose the composition of rocks and minerals, and a set of solar filters for looking at the sun. Like some new cars, the rovers also have hazard avoidance cameras, one pair on the front and one pair on the back, each looking 10 feet out to help avoid any unexpected collisions or obstacles. Spirit and Opportunity may be one-armed geologists, but those arms are highly capable, with an elbow, a wrist, and 4 modes of motion. In the mechanical fist of each arm is a pint-sized imager that acts like a handheld magnifying glass, carried by many geologists. Just as no geologist would do any field work without their trusty hammer, so each rover arm is equipped with a rock abrasion tool, or RAT. The RAT is a muscular, diamond-studded grinder. In 2 hours, it can carve out a hole 2 inches across and 1/5 inch deep into even the hardest volcanic rock. Rock interiors can be quite different from the exteriors. which have been subject to weathering and radiation and may be coated in dust. After the rat has finished its work, the microscopic imager can peer into the hole, and 2 other science instruments can be pivoted into position to study the rock. One, called a Mossbauer spectrometer, is specifically designed to study iron-bearing minerals with high precision. It takes about 12 hours to do a single measurement. The other is called an alpha particle X-ray spectrometer. It has an onboard source of alpha particles, high-energy helium nuclei. Oh, thank you so much for that cheer, Pratik. You just searched again Perseverance on Google. Yeah, it's all very exciting. Let's see, where was I? Oh, I just lost my place. It's okay. There it is. It is an onboard source of alpha particles, high-energy helium nuclei, and it can bounce either those or X-rays off the rock sample. The results give the elemental composition, which is important in deciding how different chemicals came together to form minerals within the rock. These measurements take about 10 hours per sample. The rover's suite of sophisticated instruments is completed by the miniature thermal emission spectrometer. All objects emit heat, and the spectrum of their heat can be used to deduce their composition. This instrument is particularly designed to look for minerals that can only be made in the presence of or by the action of water, such as carbonates and clays. It weighs 5 pounds and it sits in the rover's body, but it has a periscope so it can look out alongside the rover's eyes, and it can also gaze upward to gather measurements on the temperature, water vapor content, and presence of dust in the atmosphere. Finally, like many good science fair projects, the Mars exploration rovers make use of magnets. Magnetic dust grains are freeze-dried remnants of the planet's wetter past, where some type of molecules align with the Martian magnetic field when they are in solution, and then preserve that orientation when the mineral solidifies. Magnetic materials give additional clues to the geological history. One pair of magnets sits at the end of the robotic arms, where it can gather magnetized particles ground out by the rat. Another pair of magnets is at the front of the rover, tilted such that non-magnetic particles will fall off. 2 of the spectrometers that analyze any particles that stick there. That's the end of that section. Let's see if my coffee is still too hot to drink. I mean, it's scalding, but it's not that bad. Perseverance and ingenuity to scale. Ooh, let's see. Oh, that's so cool. So, Student McLeod just sent this over. So this is kind of a look at a diagram look at Perseverance and its helicopter Ingenuity. If you guys didn't know, I'm sure most of you already know, but I'll say it anyway. Perseverance is carrying a little drone-like helicopter that is going to attempt the first powered flight on a different planet, which is very exciting. And to do that, it has like super, super fast spinning blades. I think it's like 10 times the speed of what you would have to, what a similarly sized craft would do on Earth, because the atmosphere is so thin. And yeah, it's like it's stored down here right now, and when it's ready, Perseverance is gonna like drop it out from the bottom, roll back, and let it do its thing. And there's some solar panels on top so it can power itself. It's very cool. And you can see some of the stuff that all of these things that are highlighted are different things that are going to come in handy with all the science missions. You read on space.com that Ingenuity's batteries are slowly charging using electricity from Perseverance. Probably. I'm sure there's there's stuff that's hooked up in there, so like as soon as, because the last thing that they want is for somehow like the solar panels on the top of the helicopter to like break or something, or even like they probably want to, like, once it drops out of Perseverance, they want it to be able to move immediately, pretty much, just in case, because you don't want it just sitting there, especially because it's super light. They want to be able to control it if necessary. But yeah, and then it'll fully charge using its own solar cells. That makes sense. That's really cool. Because I'm sure Perseverance has can slowly funnel some energy from the rest of its from its own solar panel setup. Actually, no, it doesn't have solar panels. My bad. It's something. It's not nuclear, is it? No, it's something. We talked about this. Perseverance battery type. Oh, it's an MMRTG, which is a, hold on, multi-mission radioisotope thermoelectric generator. Yeah, so it's radioactive. I do not know the science behind how all of that works, but it allows for no solar panels on the actual rover, which is great because it saves a lot of weight and a lot of space, and you can replace that weight and space with more things to do science, which is cool. All right. The mission. Although the rover subsequently got into some amazing scapes, there was nothing seat of the pants about NASA's planning for the mission. Each of the scientific instruments was exhaustively tested in the lab and in an environment designed to roughly mimic Mars. Then, 150 potential landing sites were winnowed down to 4 and finally 2. Site selection was an agonizing process, balancing science and safety, and taking into account any steep inclines and potentially hazardous rocks in the footprint of the landing area. To the scientists and engineers involved in the mission, the launch was a double-edged sword. On one hand, after years of preparation and testing, nothing more could be done except watch the launch play out. On the other hand, $800 million of effort was on the line, and there were many opportunities for disaster. Everyone involved knew that over the previous 30 years, nearly half of the missions to Mars had been lost or had failed. On January 4th, 2003, after a journey of 300 million miles in 7 months, Spirit entered the Martian atmosphere traveling at 12,000 miles per hour, or 25 times the speed of sound. What followed... Sorry, I have to move my mic a little bit. What followed was what team members called 6 minutes of terror. The spacecraft heated up and was buffeted by winds in the upper atmosphere. 5 miles up, the parachute deployed on schedule, and then rockets fired to further slow the descent. Cocooned by airbags on all sides, Spirit hit the surface and bounced 4 stories high in a lazy arc in the weak gravity. After bouncing a dozen or so more times and traveling a quarter of a mile, it came to rest. The bouncing bag method has been used for Mars Pathfinder. It removes the need for a completely soft landing, but at the expense of unpredictable ricochets from the surface. In the control room at JPL in Pasadena, over 200 scientists, engineers, and NASA managers exhaled, and then let out a cheer. I gotta be honest, I always see that word, RAUCOUS, and I never know quite how to say it. I know what it means. Ruckus? Is it just ruckus? I think that's a different word. Oh, you lost me? We having connection problems again? Let me check my stream manager. I think we're okay. Oh. I didn't know there was an Ask Perseverance update in 12 minutes. Yeah, totally. It's totally okay if you guys got a ruckus. Yeah. Ruckus is a different word though, right? Yeah. Oh, okay, Cat Sleuth, you're back. No worries. I know sometimes there are connection problems, especially with streaming on both sides. I've had it happen to me too. But yeah, if you guys want to peace out to go watch that that Perseverance update, I understand. But also, if you want to wait until Wednesday and have a Perseverance update with me and Michael, that's okay too. They used to use plutonium in the early days. I don't know. They might be using plutonium. I forget. We definitely talked about this on Wednesday, and I just can't quite remember. That was kind of Michael's area of research. I wanted to research all the stuff about the landing and the drill and stuff, because those are the most exciting for me. Ruckus is a noun. Raucous is an adjective. Yeah. They are using plutonium? That's cool. All right. Oh, and I have a figure to show you guys. Hold on. That's why I paused. Not just because I can't pronounce words. Is it not going to let me go to the next? There it is. Thank you so much for that cheer, Pratik. Saying good night / evening / morning to everyone. You gotta head out. All right, no worries. Oh, but yeah, so I have an image for you guys. Here she is. So that is the landing site. So it's the landing site tracks and location in September of 1997 of the Spirit rover, as seen by the orbiting Mars Global Surveyor camera. Like its twin Opportunity, Spirit was designed to last for 3 months, but it was active for over 6 years and drove nearly 5 miles before getting stuck in soft sand and being declared inactive in 2011. So, yeah, so that's where it landed. You can see kind of where it's driven, and this was just after about it says this was taken in 97. And wait, I'm confused. Because it says this was taken in 1997, but that wouldn't make any sense because they weren't there. Right? I'm not crazy, right? I thought they launched in... Hold on. Yeah, they landed in 2004. Wait, I'm so confused. Is anybody else confused? When did they... Maybe that's an error? Because Spirit and Opportunity landed in 2004, right? This picture says it was taken in 1997. Maybe we just discovered evidence of Martians. I'm kidding. That was a joke. That's very strange, though. I don't know why it says that. I'm very confused. All right, I'm just going to continue reading and pretend like everything's fine. All right. Spirit landed in the Gusev crater on a rolling surface of red soil and small rocks. Opportunity landed 3 weeks later on the far side of Mars in the middle of a flat plain called Meridiani Planum, bouncing into a crater just 70 feet in diameter. Scientists were elated and called it a hole-in-one, since the crater rim seemed geologically interesting. But the result... Oh, thank you so much for that follow. Also, I've realized, I'm sure you guys are noticing this too. The alert is so loud, isn't it? It's so loud. And I don't know how to turn it down, and I'm so sorry. I'm going to try to turn it as low as it can possibly go and see if that does absolutely anything. Anyway, I'm going to keep going. Hole-in-one. Oh, yes. So they called it a hole-in-one since the crater rim seemed geologically interesting. But the result was pure luck since the spacecraft could not have been targeted that accurately. This was the first example of serendipity, or circumstance, playing a role in the mission. Spirit and Opportunity have identical hardware DNA, but their different environments began to play a role soon after landing. Both rovers went through a series of system checks before rolling gingerly off their platforms to begin exploration of the red planet. What we've learned. Water everywhere, but not a drop to drink. The most stunning finding of the Mars rovers, proclaimed the breakthrough of the year for 2004 by Science magazine, was the evidence for the prolonged presence of salty, acidic, and potentially life-supporting water on the surface. This water has long since disappeared, and climate change on Mars is the leitmotif of all the research done by Spirit and Opportunity. The Viking orbiter has provided suggestions of water, but the twin rovers provided indisputable evidence. Below the surface, there are large deposits of ice, with the possibility that some of it might be in aquifers kept liquid by pressure and a modest amount of natural radioactive heating from interior rocks. All life on Earth, from the tiniest bacterium to the mightiest redwood tree, needs water. The jury is still out on whether or not Mars has ever hosted life, but within weeks of arriving on the red planet, Opportunity showed that the Meridiani planum had once been a water-soaked plain. Pay dirt was a stone's throw from the landing site in the form of a rocky outcropping made of layers about as high as a street curb. The outcrop, nicknamed El Capitan, contained numerous clues to a watery past. Opportunity found small, hard spheres called blueberries by the science team, which were sometimes loosely scattered on the surface and sometimes anchored into rock. The blueberries were made of hematite, an iron-rich material that usually forms on Earth in the presence of water. Oxygen atoms from the water bind to iron atoms in the mineral. The team speculated that groundwater carrying dissolved iron had percolated through the sandstone to form the spheres. Later on, Opportunity discovered the mineral called jarosite, which only forms on Earth when acidic water is present. Water that's acidic or rich in dissolved iron is quite capable of hosting microbial life, as we know from the ecosystems found in places like the runoff from the Rio Tinto mine in Spain. And there is a figure that I can show you guys, and this figure will hopefully not be as confusing as the last. There we go. So this is an image of what they call blueberries that the rovers discovered. Well, Opportunity discovered. So it says Opportunity used its microscopic imager to take this picture of spherules a few millimeters in diameter. So these are super small. Just north of Victoria Crater. Nicknamed blueberries, the spherules are interpreted as iron-rich concretions formed inside deposits that had long ago been soaked in groundwater. So, cute little guys. The blueberries, I don't know why they call them blueberries. I think it was just like a cute nickname sort of thing. Yeah, it makes absolutely no sense. They're definitely not blue. They're definitely just like dirt. But I guess maybe because they reminded them of blueberries, or they're the size of blueberries. I don't know. Yeah. Parzival said, wouldn't an animation be cool if when followers follow, it appears as a black hole and then disappears? That would be so cool. If I can figure out a way to do that, I absolutely would, because that sounds amazing. I did not create the current alert box, and I think that's why we have the problem with the sound on it. Why it's so loud, because like it's a pre-made template. So I think Streamlabs is weird with pre-mades, and like you're not allowed to like change the volume or something, or there's like a weird way to have to change the volume. But if I can figure out a way to make our own custom little thing, that would be super cool, and I'll look into that. Was Sojourner in the photo instead of Spirit? It says Spirit here. I'm wondering. It only talks about Spirit here. Maybe. It's so strange. I don't know. I'll have to look into that picture later, because I'm very confused by it. Anyway, we will continue now that we've seen our blueberries. Opportunity also found inch-high rock layers that overlapped and cut into each other. Geologists call such formations crossbeds, and their sizes and shapes indicated that they had been formed by flowing water. Some layers showed weathering by wind, so the water must have been present intermittently. The minerals in the crossbeds were rich in sulfur, chlorine, and bromine, which had apparently settled to the bottom of a salty lake or shallow sea. Similar briny deposits are found in desert regions of the earth. Opportunity also found small vugs, from the Cornish word for cave, and these inch-long or smaller cavities were probably left behind when concentrations of minerals were dispersed by groundwater. Mars minerals tell the tale of a watery past. Meanwhile, Spirit wasn't spinning its wheels, yet. It had landed in a volcanic, rock-strewn plain with no obvious signs of sedimentation, but it soon roamed into its own discoveries. A volcanic rock called Humphrey had crevices filled with crystallized minerals that had most likely been dissolved in water. On another rocky target called Clovis, Spirit found traces of the mineral geothene, which only forms in a terrestrial environment in the presence of water, and telltale enhancements of sulfur, chlorine, and bromine. Spirit also measured a soil sample with a very high concentration of salt, another indirect indication of water. Science always deals with finite or incomplete information, so it's important to rule out plausible alternative hypotheses. The alternative explanation for crossbedding and other sculpting of the surface is wind erosion, but on Earth the signatures of wind and water erosion are quite distinct. Mars was volcanically active in the past, and volcanism can produce spheres from molten drops and cavities, and occasionally minerals like sulfates and jarosite. However, the web of chemical evidence from the rovers, plus the features that can only be explained by the action of water, present a compelling case for an ancient Mars with water on its surface. The finding of past water on Mars raises more questions than it answers. Mars has an obliquity, or a tilt of its axis as it orbits the Sun, that varies much more than the Earth's. Orbital tilt causes seasons on any planet, whereas our tilt is stabilized at close to 23.5 degrees by the Moon. The tilt of Mars is known to have varied from 10 to 60 degrees over the past 100,000 years, and dramatic climate variations were probably occurring in the distant past as well. The idea of a warmer, wetter Mars several billion years ago is appealing, but is not well supported by climate models and evidence from Martian meteorites. The problem is that the planet's modest gravity is incapable of retaining a thick atmosphere, and the early Sun was fainter than it is today. Some 65 to 70 degrees of greenhouse warming were needed to bring the surface up to the melting point of water. And while Mars did have early volcanism that generated carbon dioxide, which is a heat-trapping greenhouse gas, the early atmosphere was unlikely to have been thick enough to get the surface temperature above freezing. Mars climate changes continue to be enigmatic and difficult to pin down. And that's the end of that section. I'm going to take a quick drink of coffee. And I think, if you guys don't mind, for just a minute, I might dip out for a second, run to the bathroom, get some water, because it's probably good to drink both water and coffee, not just coffee. And I'm going to send you guys to a quick little ad break, as long as you don't mind. So I will be back in 1 second. returned. I hope you like the music. Quick question. I don't know if Twitch is lying to me or not. If anyone got an ad during that, let me know. Or if you get ads before you get here or anything, because I know that subscribers definitely don't. But I don't know if it's just lying to me and saying that it's giving you guys ads and therefore should be giving me a couple cents. Okay, one of you got an ad. Parzival didn't get an ad. No ad. Okay. Astro Kiriani, I think you're a subscriber though, right? Yeah, you're a subscriber. So you shouldn't get them. You check the NASA site. The two Vikings launched in 1975 and landed in 1976. Sojourner landed aboard Pathfinder in 96. Spirit and Opportunity, Curiosity. Okay. So then what the hell is this about? He must have... This must just be a typo then, because this has to be talking about one of the... it has to be talking about Sojourner, right? Instead of Spirit. Because, like, I would think it would be like, oh, maybe they just, like, drew it in kind of thing. But or like you know, they were like mapping it and they took like an image from before and just like mapped it out, but like you can definitely see like a trail of where it drove. So I think it might have just been a typo or something, and it might have actually been Sojourner's path and not Spirit's, because that's very strange. I could totally send you guys the link to the music. I will do that at the end of the show, because I have to go find it in it's all free music from YouTube. The date of the photo, it says here, was September of 1997. So it says here, the landing site, tracks, and location in September 1997 of the Spirit rover from the Mars Global Surveyor camera. And it definitely talks about Spirit. And it gets the inactivity date right, because it was in 2011. So it must just be, I don't know. Just enjoy the picture. Yeah, I'm just confused. We'll say it's Sojourner, or that it's the wrong date. Either way, we can continue. But yeah, I'll send you guys at the end during the outro sequence. I'll put a link to some of the music that I used. Give Chris a heads up in case there's ever a second edition. Will do. What is that link? Let's see. Oh, the Martian spherules. Yes, there's a whole page about the blueberries. That's so funny. If you guys are interested, Astro Kiriani just put a link to an article about the blueberries. It worked. The link worked. I don't know if you... for some reason, sometimes it looks like half the link is not actually hyperlinked, but it still works, so... Go check out the blueberries. Okay, let's keep on going. The little rovers that could. With all the human inspiration and perspiration that was poured into Spirit and Opportunity, it's hard not to anthropomorphize these little robots. Engineers and scientists on the project are clear-eyed and level-headed for the most part, but they've ridden an emotional roller coaster as their twin progeny encounter challenges and make discoveries. In their very different experiences on Mars, the rovers acquired distinct personalities. We can think of them as lucky Opportunity and indomitable Spirit. Opportunity's charmed life began when it landed 15 miles downrange of its intended landing site, careening into a crater, and found itself near rocks bearing signs of formation in water. By late 2009, Opportunity had roamed nearly 12 miles across the Martian landscape. First, it was sent on a kilometer jaunt to Endurance Crater. Entering the crater was a risky proposition. the team was resigned to the possibility that it might not get back out. Despite wheel slippage and tilting up to 30 degrees, Opportunity spent 6 productive months exploring the crater floor and got out again safely. Soon after leaving Endurance Crater, it had another stroke of luck. Sent to examine its own heat shield, it noticed a basketball-sized iron-nickel meteorite, the first ever found on another planet. On March 25th, 2005, Opportunity set the one-day distance record for either rover, 720 feet. It then got stuck in the Purgatory Sand dune for almost 3 months, extricating itself an inch at a time. The rover had always had a bulky shoulder joint as a result of a failure of the switch that controlled the heating unit, and as a result, the motors were in danger of wearing out. In 2008, as a last-ditch measure to save the arm, engineers stopped stowing it at night, so Opportunity now travels with its arm held out in front of it, like a blindfolded person afraid of stumbling into an obstacle. More good fortune came Opportunity's way in 2007. Choking dust storms reduced sunlight by 99%, and power from the dust-cloaked solar panels was dangerously low. In a turn of events that was almost miraculous, the rover was restored to nearly full power by a series of cleanings, most likely dust devils that whipped the dust off the solar panels. Since then, Opportunity has continued its work with the endurance of a long-distance runner, pausing only to wait out the frigid Martian winters. It made the 4-mile trek to Victoria Crater, and after cautiously exploring a quarter of the perimeter, it found a safe way down and worked there for nearly a year. In August 2008, it set out on its most ambitious journey yet, a 3-year, 8-mile journey to the huge Endeavour Crater, some 14 miles across. In keeping with its history, oh, thank you so much for the follow. Parzival, you weren't following before? I thought you were following. Is this a different account? You don't know. Well, welcome back to the TeachAstronomy family. That was funny. Where was I? Victoria Crater. My crater. It's named after me, guys. They named it after me. Where was I? Okay, there we go. In keeping with its history, in April 2009, its power was boosted 40% by a cleaning event, and it continued rolling purposefully toward a new set of adventures. After a detour in early 2011 to explore the quarter-mile diameter Santa Marina crater, Opportunity trundled on toward Endeavour. In August 2011, it reached its goal and gained access to geological samples from an earlier period of Martian history than any it had found so far. At an outcrop on the lip of the crater, Opportunity found zinc concentrations that were indicative of water, and a bright vein of hydrated calcium sulfate that Steve Squires called, quote, the clearest evidence for liquid water on Mars that we have found in our 8 years on the planet, end quote. By the end of 2015, its odometer had clocked a marathon of over 26 miles, a Homeric distance for such a tiny traveler. Its metallic carapace becomes still and silent each Martian winter, but each spring, when the tepid sun returns, it continues its epic journey. And I don't know if it's still alive. Let's find out. Opportunity rover. Because again, this book was written like 10 years ago. I don't believe it is. Yes, okay. Oh yeah, Opportunity said goodbye just a couple years ago. Its last contact was in 2018, and it was declared the end of the mission on February 13th of 2019. So it lasted a hell of a long time. It was only set to last 90 days. And instead it lasted, what is that? 16 years? 16 years? Insane. But yeah. You have some trust issues with Twitch. Me too, man. Yeah, it's only curiosity and now perseverance and ingenuity. Yeah. All right. Spirit story is like a lesson in biology. The two rovers have identical genetic material, yet an unpredictable environment gave one of the rovers a much harder road. Spirit's first brush with disaster occurred less than 3 weeks after it launched, when it suddenly stopped talking to mission control. It got stuck in a reboot loop, where a fault occurred during reboot, with the risk that the loop could continue forever. If it had been a hardware fault, it would have been fatal. However, the culprit turned out to be the flash memory, and careful management of that resource solved the problem. Spirit had always had trouble with one of its wheels, but that didn't stop it from clambering up Husband Hill, taller than the Statue of Liberty, oh my god, and working so diligently with its rat that it wore out the diamond bits on the drill. In March 2005, it even got a taste of opportunity's luck when a dust devil boosted power delivery from its solar panels by 50%. But a year later, JPL announced that Spirit's bad front wheel had stopped working altogether. After that, Spirit drove in reverse, dragging its wheel uselessly in the dirt. In December 2007, the dead wheel led to an important discovery. It scraped off a surface layer to reveal bright and pale material that was rich in silica. This find could only have come about in 2 ways. Either hot water in a geyser dissolved silica in one place and deposited it somewhere else, or acidic steam percolating upward through the rocks stripped them of their other minerals, leaving silica behind. Both of these scenarios are familiar on Earth, and both are situations here that teem with microbial life. After that, Spirit needed all of its reserves of pluck and stoicism. Dust storms throughout 2007 and 2008 kept Spirit's power dangerously low, often on the point of total system failure. Early in 2009, beneficial winds increased the power level. That spring, at the base of the Columbia Hills, Spirit's left side broke through a dark crust and got embedded in pale, loose sand. This material is iron sulfate, which has almost no cohesion, and so the rover wheels cannot get a grip in it. This time it was not a discovery. It was major trouble. While Spirit idled at this site, called Troy, engineers tried to figure out a solution. At NASA's Jet Propulsion Laboratory and elsewhere, fans of the rover sported Free Spirit t-shirts. Progress was painfully slow. For example, on November 21st, 2009, a series of commands to drive 16 feet produced just 1/10 of an inch of forward motion. As part of its aging, Spirit also experienced memory loss. After 9 months of futile attempts to get out of the sand trap, NASA made lemonade out of lemons by declaring Spirit a stationary science platform. After nearly 5 miles of roving, it had come to the end of its road. JPL lost contact with Spirit on March 22, 2010. By May 25, 2011, after more than 1,300 commands without a response, the recovery effort was terminated. Spirit had finally succumbed to the vicissitudes of Mars. Poor Spirit. The rovers did so well. Just goes to show you, though. You can be just like someone else, but if your circumstances are different, you can live very different lives. There's like a lesson in there somewhere, I'm sure. All right. Gosh, this chapter is just so long. Like, I'm having a good time. It's very interesting, but like, oh my goodness, it's very long. Okay. Meet the rover drivers. Behind every successful robot rover, there's a driver. Actually, 14 drivers in the case of Spirit and Opportunity. For those people used to the gray male gristle of the typical scene... Okay, I thought I read male wrong because I was like, that seems weird. No, it is. The gray male gristle of the typical scene at Mission Control in Houston. The rover drivers are surprisingly young, and many are women. Drivers don't control the rovers in real time with a joystick. The reasons are that real-time control would be far too hazardous, and there's no immediate feedback. Depending on where the Earth and Mars are in their orbits, the distance can vary from 35 to 200 million miles, and the time delay for a signal can be as high as 20 minutes. The drivers are part of a much larger team of engineers and scientists, numbering over 200, who are all involved at some level in what the rovers do. On a typical day, the results of the previous day, which are part of a larger strategy involving weeks or months of roving, are evaluated as quickly as possible, usually within an hour. Then the drivers work with the science team to map out the day's activities, which might involve measurements of an interesting rock or navigating around obstacles. This is turned into a set of commands that the rovers can execute. Commands are turned into a realistic animation and reviewed with the science team. Then they are picked apart for anything that could go wrong. All possible contingencies are considered. The final list of commands is reviewed twice and sent to the rovers to execute. Then the process starts again, and it has for over 2,500 days. The only break comes during each Martian winter when the rovers hibernate and conserve power. There is a catch. A Martian day is 40 minutes longer than a Terrarian day. Terran? I'm sorry, I know they mean like an Earth day, but I've never heard the term Terran day? But a Martian day is 40 minutes longer than Earth day. So each day, drivers begin their days 40 minutes later than the day before. As driver Scott Maxwell has said, quote, "Pretty soon, you're starting your day at midnight, at 2 a.m., at 4 a.m. It's been called Martian jet lag. It's tough on bodies, on brains, on relationships." End quote. It leads to fatigue, which leads to mistakes. So many drivers watch their caffeine intake and keep to Mars time even on their days off, which puts further strain on relationships and adds to the otherworldliness of the job. As for what it feels like to control a robotic vehicle on another planet, listen to Ashley Strope, one of the most experienced drivers. Quote, "It's really just awe-inspiring. Probably the closest I'll ever get to being an astronaut. Going to new places and being the first human eyes to see them is profound and hard to describe. It's the best job I could imagine." End quote. Be warned, watch out for the male gristle. Terra means earth in Latin. Yeah, I'm assuming it's because it's Terran. So I guess it's just a term for an Earth day. But I thought it was, I had never heard it before. Also, I have a picture for you guys to see. Here we go. It's not a great picture. I had to wrong one. I had to pull it from the book, this one. But it says, Scott Maxwell works at NASA's Jet Propulsion Laboratory and is a senior driver for the Mars exploration rovers. Maxwell has a background in computer science and was a software engineer before becoming one of the rover drivers. He recounts his experience on a blog called Mars and Me. So if you guys ever want to check it out, go to marsandme.blogspot.com, apparently. All right. The different personalities of the rovers project into the driving experience, as Strope explains. Quote, "The rovers do behave differently. Spirit and Opportunity are first, in very different terrains, and so you have to drive them differently. Also, they have aged differently and have driven us to use very different strategies. We have to drive Spirit mostly backward to drag the broken right front wheel. And we have to drive Opportunity with the robotic arm out in front since one of the joints broke and we can't stow it anymore." End quote. There are also light moments, as Maxwell describes in his online blog. Quote, "Early in the mission, we nearly lost Spirit due to a problem with its flash file system. When we diagnosed and fixed the problem, cleaned up the flash drive, and knew that the danger was past, someone wrote this on one of our whiteboards. Spirit was willing, but the flash was weak." End quote. His greatest driving challenge was trying to get Spirit to a safe haven for the winter by driving across a dune with a bulky wheel. As he said, "Imagine trying to cross a desert pushing a shopping cart with one stuck wheel." That's the end of that section. He looks happily frustrated, and as an engineer, you can understand him. Yeah. I mean, I can't imagine having to figure out how to drive that thing. Like, it's hard enough to, do software fixes and stuff like that and engineering stuff when you can actually like work on the physical object, or terrified. But then when it's 200 million miles away on another planet and all you can do is just like ask it to do things for you, it's crazy. Hell of a challenge. All right. Mars is kid stuff. Many of the rover drivers are younger than 35 years old. In general, planetary science is an older man's game. It takes more than a decade to plan and execute a space mission, and the proportion of women in the profession has been growing, but from a low base. However, NASA understands that the vitality of the space program depends on inspiring young people and broadening the participation of women. The Mars exploration rovers have set a strong example of engaging the next generation. It started with a third grader naming the rovers, as we saw in the opening vignette. The trail was blazed by 9 kids aged from 10 to 16 from around the world who won an even earlier essay contest. Their prize was to have guided a robotic rover on the Mars Surveyor mission, but that mission was canceled. In March 2001, they came to the United States to work with the Mars Global Surveyor Orbiter, where they became the first members of the public to ever command a NASA mission. The next set of 8 students was selected from thousands of applicants who had to write a journal saying how they would use a rover to explore a hypothetical site on Mars. Aged 11 to 17, they came to JPL in Pasadena in 2002 to simulate 2 days of exploring Mars with a prototype of an advanced rover called Fido. They experienced the same training given to mission team scientists. All this led to the selection of 16 student astronauts from another international essay contest, sponsored by the Planetary Society. The 8 boys and 8 girls, ages 13 to 17, came to JPL in early 2004 and were the first group of kids ever to participate in the daily operations of an ongoing Mars mission. They were in the thick of things as Spirit and Opportunity made some of their most interesting discoveries. Snippets from the children's online diaries give a sense of their experience. Courtney Dressing from the United States said, quote, "Today was definitely the best day of my life. Spirit landed on Mars," end quote. Satvik Agarwal from India said, quote, "It's really amazing how scientists just stop with whatever they're doing and explain it to us without feeling irritated," end quote. Kristen Rosenak from Canada commented, quote, "Today has been a very exciting sol. I can't wait to start working on new images for these sols and on the other rover," end quote. Camelia Zenden from Great Britain. "The overall message from all meetings is one of enthusiasm. Just keep on trucking. I must admit that I still can't believe that I'm actually here." A follow-up of these young people 5 years after the rovers landed showed that almost all of them are pursuing science degrees and heading for careers in science or the aerospace industry. Their passion for science is undiminished. Their dreams of other worlds were nurtured profoundly. They, of course, were lucky enough to have a singular experience, but the Mars rovers have also reached into the lives of a much larger number of people. Wait, what kid stuff? I know, the way that they say it, it's a definitely interesting section title, but I like it. It's cool. NASA is very into trying to get people and young people involved in what they're doing, which is awesome. And not just young people from the United States, clearly, young people from all over the world. The broken shopping cart is a good analogy. I like it. Daft Punk is disbanding. Oh, that's very random, but unfortunate. Yeah, it's hard enough to push a broken shopping cart through the aisles of the store, right? And then imagine pushing it through a bunch of sand. All right. There's a video update of the landing. Oh, the landing. Oh, is the video of the landing available now? Like from Perseverance? Because that's exciting. I'm not supposed to watch it until we watch it on Wednesday, but I want to watch it. I'm just really excited to see and hear like I'm really excited to hear the sound of it, because like this is the first time they've had mics on it, and I'm a sound nerd. Most of you don't know this, but I did a lot of production sound in college. I think I did production sound on like 5 or 6 short films, and edited like 3. Yeah, there is a press conference going on right now. We will cover it on Wednesday, because unfortunately, I have to keep reading the book. It's an interesting book. I do want to know what's going on, though. Going back to the odd T word you paused on. Oh, if you invited someone from Venus, Mars, and Earth to your next cookout, your guests could introduce themselves as Venusian, Martian, and Terran. Oh, yeah, okay. Gotcha. That makes sense. Venusian. No, Venetian is something else. That's Venice, not Venus. They're very close. You gotta get that emphasis correct. But thank you for clearing that up. That makes more sense. I would like to have a party like that, like a little cookout. I am the Terran, yes. All right. Mars is also child's play. To many people, participation in the space program seems completely unreachable. It requires too much training, too much specialized knowledge, and the hardware is too expensive for non-experts to understand the issues, let alone be players. This mindset ignores the great facility of the net generation with computers, games, and simulations, and it ignores the soaring aspirations of young people who have not yet tested their limits. To baby boomers who lived through the fallow years that followed the Apollo moon shots, space travel is hard. To millennials who are witnessing the opening of space to the commercial sector for the first time, space travel is natural and inevitable. Random question. But because he mentioned it in here, what generation are you guys all from? Because I'm right on the cusp of millennial and Gen Z, but I think I'm millennial based on the way that like I was raised. Parzival's a Gen Z. I want to see what our demographic is here. Baby boomer? 2 baby boomers, yeah. A millennial. Another boomer, 2 boomers. Lots of baby boomers, yeah. I know a lot of you we have a good number of baby boomers that do the do Chris's courses as like lifelong learners. So I'm not surprised that we have a lot of you here, but it's cool to have a couple other people from different. We clearly span a lot of age groups, which is cool. It's really fun. All right. The student astronaut program and its precursors were spurred by an unusual collaboration between a nonprofit advocacy organization, the Planetary Society, an agency of the federal government, NASA, and a well-known corporation, the Lego Company. Their project was called Red Rover Goes to Mars. It was preceded by a project called Red Rover, which began in 1995. The executive director of the Planetary Society, Louis Friedman, saw a teacher at an educational workshop using a Lego product called Control Lab, which let students build motorized devices that could be controlled by a computer. He immediately saw a parallel to the robotic exploration of Mars. If kids could sit at a computer and control a rover in another room or another country, they could experience the challenges of controlling a rover on another planet, a world that can only be explored through the limited senses of a robot. Starting in 2003, a network of Mars stations was set up around the United States, and in Britain and Israel, each equipped with a different Mars-like terrain and a Lego rover with a web camera. Anyone who wants to can drive these rovers over the internet. Lego Education has products such that any kid can build and drive their own rover, assuming their parents don't object to the creation of an artificial Mars in the family home. Another idea designed to appeal to kids was the inclusion of a Lego minifigure on each of the Mars exploration rovers. Biff Starling and Sandy Moondust were named in another competition as they each authored freewheeling online diaries as the rovers explored Mars. Each Lego figure was attached to a mini DVD and before the rovers rolled off into the Martian dust, they took a few pictures looking back. It's a little incongruous to see Lego on Mars. 4 million people have their names on the mini DVDs. Many are members of the Planetary Society, and the rest signed up on the Planetary Society's special website. This was only the second time privately developed hardware has flown on a planetary mission. Through these partnerships, the lure of space travel has been extended to a very wide audience. The Martian dreams of today's kids are very different from the dreams of kids 4 generations ago, which were fueled only by pulp fiction and fantasy. Boomer is Wrigley's Company chewing gum. What? I don't know what that means. You're one of his students, yeah. Hello, Mr. Mordo, 2020. Welcome. Oh yeah, definitely take Professor Impey's course on astrobiology when you're finished with the regular astronomy course. I edited the original course, not originally. That was like way before I was a part of the team, but because I think that launched in like 2010, and I didn't even start with them until 2017. But like 2012 maybe. I don't know if that's when they did it. But yeah, I helped edit that and bring it up to correct accuracy because a lot of things have changed. I think even James Webb was said to launch like 8 years before it, before now. But yeah, that's a really good one. They're both good. And I think we're going to be having a new one soon. I don't know if Matthew's mentioned it much or if anything's actually gone up, but Professor Impey taught an online class at the University of Arizona this past semester. And it was all about the history of astronomy, which was really interesting because I got to, I did edit that one. And he taught it as like online lectures because we didn't have classes in person due to COVID. And he thought, well, why not make this an online course as well? So that will be coming soon. I believe they're still figuring out all the online assignments and stuff because, the assignments are going to be different for a massive open online course than a regular university course, but that should be coming eventually. So that'll be exciting as well. And I edited that and made the fancy intro sequence. So when you see the fancy intro sequence, you'll know that was me. Am I a scientist? I am not personally a scientist. I have worked with a group of astronomers for the past 3.5 years now. Wow, that's a long time. What the hell? Because I started in April of 2017, so 2018, 2019. Yeah, it's like gonna be 4 years in April. Oh my god. Okay, that's wild. That's very strange for me. But I'm not a scientist. I studied film and television. I have a bachelor's degree in that from the University of Arizona, and I've been working with this group doing a lot of the film and TV side of things. I have learned a lot about astronomy through this, so I would say I have a better than layman's understanding of astronomy stuff, and I can answer some of your questions, but I am not the specialist in our group. I would pass that off to Michael and Matthew, and obviously Professor Impey, because they are the ones who study this and got degrees in specifically astronomy. But yeah, can you watch some of my works? Oh, like my film stuff? I have like one thing available. I don't know if anyone cares about that. I think, no, maybe I have like 3. I have like 2 high school films and a documentary I made in college that I'm actually pretty proud of on my YouTube channel. I don't know if anyone's actually interested. Maybe I'll link it. Final project for Doc's astrobiology course is supporting your choice in a NASA proposal for which exoplanet to send astronauts to. That does sound really interesting. I actually think I'm going to be looking at that, looking at some of those writing things, because we may be writing a paper on that, I believe. I think there's like a disclaimer thing if you sign up for the course that we might be using it as some research stuff, but we want to see if it's actually like working and people are actually learning, and if these courses are valuable, because we want other people to know that these courses are valuable, because I think they are. So yeah. All right. I guess if you want me to link, I'll link my YouTube page. Why not? What the hell? No one ever goes to it. Give me 1 second. I'll find it. I haven't, so my two big projects are, I have like 3 videos here. One is very cringy from like 8 years ago, starring my brother. But one of them is a pretty interesting documentary about vinyl records in Tucson, Arizona, and like the vinyl industry, which I think is cool. I also have a senior film project that I don't have public, but I'll probably make public eventually. That was like my big thing. And I also make a podcast that is on it's going to be its 3rd season soon. It's called Cryptid Cape, and it's a fictional podcast. Here's a sticker of it. You can find it wherever. But it's a fictional podcast about a girl who's trying to find her way in the world in this new town that she moves to, that she finds out is full of cryptids, and she's the only human in this town full of cryptids. And we actually just got picked up recently by a different network that is going to start helping us with advertising and marketing. So that's pretty exciting. But yeah, that's kind of what I do outside of this, if you were ever curious. Yeah, the sending astronauts to an exoplanet, that is definitely a theoretical idea thing for a course. So just kind of a thought experiment more so, because they definitely wouldn't make it unless we were able to find a way to, do light speed travel, or very close to light speed travel. So that was just a thought experiment sort of thing. I think it was more for the like, why would you want to do this, and like, how do you understand the science, and how does that influence your choice, sort of thing. But yeah, he does look like Charles Darwin. He's a great guy. Not Charles Darwin, I don't know him, but the guy in the vinyl video. All right, let's see. Back to the book. A Planet with a Traveler's Guide. In the sleepy community of Redlands, California, on the local library shelves designated Astronomy and Allied Sciences, one book stands out for its well-worn, bent, and torn cover. It's A Traveler's Guide to Mars by planetary scientist William K. Hartmann. Advertised as an extraordinary Baedeker, the text is published in the format of the famous travel guide. Having sold so... Okay, I'm sorry. I just paused because I was like, wait, did I actually finish the section before this? I did. It's okay. Anyway, having sold so well, the publisher reissued a second printing within the first 2 months of publication. The travel guide details features of the Martian surface. The adventures that await inside its pages include familiar and unknown craters, volcanoes, ancient river channels, and floodplains, as well as the guide's fold-out maps, dramatic color photographs of key geographical locations, and sidebar articles on featured terrain. This isn't a book for youth, but a serious guide for those interested in Mars. Readers are informed that they would be among the first to examine previously unpublished Mars Global Surveyor photos, as Hartmann served on the imaging team for that mission. His Martian travel guide offers serious analyses of geological formations in parallel with sidebars such as What to Wear, a look at Martian weather. Readers learn that typical daily temperatures span from negative 13 degrees Fahrenheit during the afternoon to negative 125 degrees Fahrenheit at night, and that the extremely thin carbon dioxide atmosphere and low barometric pressure are inhospitable for human survival without protective gear. To familiarize travelers with the Martian night skies, Hartmann explains, quote, "The stars are brilliant at night after the glow of hazy sunsets fade, and the constellations are the same as the ones we see from Earth, with one exception. A blue glowing evening star with a faint companion star is sometimes prominent for an hour or so after dusk." End quote. One of Jim Bell's panoramas, almost certainly inspired by Carl Sagan, similarly captures captures from Gusev Crater a view of our pale blue dot on the Martian horizon. Thank you so much for that follow, Less Sugar 92. Welcome to the words. I tried to say amateur and then I tried to say astro. The TeachAstronomy family. Welcome aboard. Travelers dulled by the been there, done that aspect of some earthbound excursions might consider the many fascinating destinations available via Google Mars. I didn't know that was a thing. Which offers virtual tours of Mars and commentary about major landmarks, excerpted from Hartman's travel guide. Developed in collaboration with NASA by a Google team led by Noel Gorlick and launched in 2009, Google's Virtual Mars was designed so that planetary scientists and general users might have ready access to a rich photo archive of past and current missions. Like Google Earth, click and zoom functions allow users to examine planetary features in 3D, as well as images from multiple NASA and ESA missions, including Viking, Pathfinder, MER, Mars Global Surveyor, Mars Reconnaissance Orbiter, Mars Express, and Mars Odyssey Orbiter. Geographical and geological highlights are indicated with icons of 2 green mini hikers to reinforce Hartman's Baedeker motif. Users might follow the tracks of Spirit and Opportunity, locate the Viking landers, peer over the canyon rim into Valles Marineris, or alter the perspective to the canyon floor, from which Hartman notes its walls can soar upward for 13,000 feet. Even more stunning are the spectacular landscapes produced at the University of California, San Diego, in what is called the Star Cave, a 3D, virtual immersive environment the size of a large closet that allows researchers to explore stretches of Martian terrain. The MER rover PanCams, developed through a collaboration of the NASA Ames Research Center, Carnegie Mellon University, and Google, produce high-resolution photos that can be configured as highly detailed 360-degree panoramas. The Star Cave panoramas extend across the floor and to the ceiling, so that planetary scientists can virtually explore the Martian landscape in situ to search for clues regarding soil deposition, wind and water erosion, and other geological processes. Using a handheld device to navigate the immersive environment, researchers can zoom in to rock or sediment layers, or zoom out to survey the broader lay of the land. Larry Smarr, who heads the California Institute for Telecommunications and Information Technology, CALIT-2, that operates the Star Cave, comments on the value of doing serious science in an immersive setting. Quote, "You can go into a room and you're on Mars." He explains that the rendering is so fine that planetary scientists in effect can walk through the landscape, study rocks and geological features up close, as well as understand a site in relation to surrounding terrain. In the Star Cave, users must wear 3D glasses, but with the personal Verrier technology developed at the University of Illinois, Chicago, researchers can work in immersive virtual environments without any headgear, somewhat like the fictional holodeck posited in the TV series Star Trek: The Next Generation. Even now, researchers use this technology to engage with a variety of environments, such as walking through the temples at Luxor or exploring, from the inside, a molecule or a segment of the human genome. The public impact of these emerging virtual learning environments will be profound. Both NASA and the U.S. Congress are interested in using similar technologies to make planetary science more accessible to everyone. So much so that the House of Representatives in its 2008 NASA Authorization Act invited the space agency to develop means by which general audiences can experience missions to the Moon, Mars, and other bodies within our solar system through technologies such as high-definition video, stereo imagery, and three-dimensional scene cameras. For now, Google Mars and the immersive environment of the Star Cave, or personal Verrier, reminds us that, whether in orbit or on the surface, our robotic partners precede us and increasingly unfold and make familiar nearby worlds. That's the end of that section. I pronounce it well. I'm glad. Thank you. I'm just guessing, you know. Let's see. Oh, Ooh, Google Mars. Let's look at this. This is fun. Nope. Nope. Hold on. Oh, I see what it did. Opened a new window. There it is. This is Google Mars. This is cool. How deep can we get it? We can get pretty deep. This is pretty cool. Let's see. What do we want to see? Spacecraft. What are we looking at here? Who's this one? That's Mars 2 lander from the USSR. Let's look at Perseverance. There she is. There's Perseverance. Where's Insight? Oh, they're not too far away. Oh, someone's very close. Who's that? The Beagle 2 lander is a British lander. Oh, it failed during descent. Well, that's sad. Who's over here? The Viking 2 lander. Okay, this is something that you can really get into. So I should probably shouldn't do this right now. But that looks really cool. Sounds like AR and VR work could build on your background. On my background? Maybe. Yeah, it does look like a painting from far away. It's very cool because it's all this is the. Oh yeah, let me show you. I'll show you again for 1 second. So this is the elevation map. So it shows, elevation. This is the visible map, and I don't know what's going on with that split there. I'm not sure. And this is the infrared. So that's pretty cool. There are some areas that seems like it's more well mapped than others. Yeah, we got like really close pictures of some places, and yeah, cool stuff. Definitely something you can spend some time checking out. All right. Popular discourse on interplanetary travel. Former NASA historian Stephen Dick recounts the claims, first by American physicist Nikola Tesla, and a few decades later by Italian innovator of wireless technology, or wireless telegraphy, Guglielmo Marconi, that they had received wireless signals from Mars. Collier's Weekly in 1901 reported that Tesla was convinced he was the first to hear the greetings of one planet to another, and that the supposed radio signals were most likely from Mars. By the early 1920s, Marconi apparently repeatedly attempted to receive short-wave radio messages from Mars. Dick writes, quote, Marconi's interest in interplanetary communication peaked during a trip from Southampton, England, to New York City aboard his yacht, the Electra, from May 23rd to June 16th, 1922. The New York Times noted that Marconi spent the time crossing the Atlantic performing many electrical experiments, principally by listening for signals from Mars. End quote. William Sheehan and Stephen O'Meara reported that 2 years later, when Mars was at its closest since 1804, quote, the radio stations around the world were urged to simultaneously cease transmissions at specified intervals, so as not to interfere with any attempts by Mars to radio the Earth. End quote. Even the U.S. Navy, notes Dick, monitored radio transmissions for potential Martian messages. News reportage of such events may be the reason so many assumed a Martian invasion in October 1938 when a radio broadcast, seemingly interrupting the Mercury Theater on the air programming, indicated Martians had landed at the Wilmarth Farm in Grover's Mill, New Jersey. Orson Welles' radio presentation, discussed in Chapter 1, is one of the most singular events in radio history. As Bruce Lenthal points out... Sorry, getting tongue-tied. As Bruce Lenthal points out, broadcast radio was a major news source in the early 20th century. For audiences in the United States, Lenthal claims, quote, radio ownership more than doubled in the 1930s from about 40% of families at the decade's start to nearly 90% 10 years later. By 1940, more families had radios than had cars, telephones, electricity, or plumbing. End quote. Linthal estimates that 6 million people actually heard the radio play that Howard Koch adapted from H.G. Wells's The War of the Worlds. And of that number, approximately 1 million listeners literally thought that Martians had landed. Subsequent to Tesla and Marconi's independent claims of having detected radio messages from Mars, some contemplated whether Mars was inhabited by a sophisticated civilization whose radio signals the authorities had been listening for. T.S. Eliot noted in the poem The Dry Salvages that popular commentary on means to communicate with Mars was one of the usual pastimes. Perhaps interplanetary travel from Mars didn't seem entirely fantastic, given that the 20th century emerged as an unprecedented era of global travel. In the first few decades of the century, train and ocean liner travel expanded exponentially, while motoring and flight, first achieved in 1903, quickly developed as everyday experiences. Large numbers of people became mobile in ways that just a few years prior had been extremely arduous, or even unimaginable. With the serious development of rocketry in the 1920s and the genesis of the American Interplanetary Society in 1930, followed by the British Interplanetary Society in 1933, travel between Mars and Earth may have finally seemed possible and well within the realm of the imagination. With large numbers for the first time traversing multiple time zones in a day, British author Virginia Woolf suggested that people began to internalize in finer detail Earth's global topography. She claimed that her own travel experiences afforded her a better sense of Earth's surface, so that she could easily imagine and rehearse its large topographical contours. When she and her husband Leonard bought a used automobile from sales of her novel To the Lighthouse, Woolf observed that monitoring had been, quote, a great opening up in our lives that allowed her to expand that curious thing, the map of the world in one's mind. End quote. As early as 1909, while traveling through Italy, Woolf recorded in her diary, quote, "It is strange how one begins to hold a globe in one's head. I can travel from Florence to Fitzroy Square in London on solid land all the time." End quote. She meant that she could easily envision the contours of Earth's globe, as if she could turn the Earth around in her fingers and trace its continents, mountains, islands, and shorelines. Coincident with the increase in global travel in the first few decades of the 20th century was the construction of a new generation of large telescopes, like the 100-inch at Mount Wilson Observatory. News reports covering astronomical discoveries frequently appeared in newspapers and weeklies, so much so that references to lunar and planetary landscapes were taken up in advertising and in the common parlance. In January 1926, while motoring through Persia, Woolf's close friend and celebrated author, Vida Sackville-West, wrote to Virginia describing the hills near Thebes in Egypt as a mountains of the moon landscape. A year later, in March 1927, Sackville-West was again touring in Persia and wrote to... Did I say Persia before? I'm so sorry. It's Persia. Oh. Anyway, she was again touring in Persia and wrote to Woolf from Tehran, quote, "There is one little asteroid, called Ceres, I think, only 4 miles across, the same size as the Principality of Monaco, on which I have often thought I should like to live, revolving in lonely state around the sun." End quote. Presumably, Sackville-West had read a news report regarding our largest asteroid, currently estimated at 975 kilometers, or 606 miles in diameter. Prompted perhaps by Vida's evocation of other planetary landscapes, Woolf in September that year noted in her diary, quote, "What I like about motoring is the sense it gives one of lighting accidentally, like a voyager who touches another planet with the tip of his toe, upon scenes which would have gone on, have always gone on, will go on, unrecorded, save for this chance glimpse." End quote. Decades later, Spirit and Opportunity offered our first extensive, close-up glimpse of Martian geological processes that have gone unrecorded for eons, and what we have found allows us to more fully internalize the red planet's landscape and its geomorphology. That's the end of that section. Google has a similar map of the moon. No way. Oh my god. Amazing. Use Control Plus. This is very cool. So there's Google Moon. Amazing. And then Wells in his studio scaring his audience. Yeah, that's him. That's cool. Yeah, it makes sense that they only have the two celestial bodies right now. Well, and Earth, in quite high detail, I would say, for Earth, because we haven't really landed on anything else that we could stay on, because we've landed on Venus for about an hour, I think was the record, before we were violently crushed. Yeah, we do have to send more missions. Okay, we've got a few more pages. We can do this. It's already been 2 hours, but we're gonna get through this chapter. Venus is great. Venus is one of my favorite planets. They have Google Sky. Amazing. I'm sorry, that was loud. But they even have Google Sky. This is insane. The more you know. Thank you guys for those links. These are great. Maybe one day we'll just play around with those on a Wednesday non-news stream and just be like, where should we go today? They should have a geo-guesser for other planets. I don't know if you guys have ever played GeoGuessr, but it's fun. Okay. Travel narratives for the 21st century. By the late 1960s and early 1970s, the moon landings had become the grand travel narratives of human history. Mars had subsequently emerged as the next great travel destination. There are multiple reasons why the planet so intrigues us. Through MER and other missions, Mars has become familiar and tangible. While our oceans obscure 70% of Earth's topography, on Mars we can visually survey the entire surface, so that planetary scientists to some extent have a better understanding of its surface than of our home planet. Global Surveyor's multicolored elevation maps, for instance, reveal that Mars's northern hemisphere lies low in elevation compared to the southern highlands. Far fewer impact craters in the northern hemisphere may indicate that at one time this region was covered by a primordial sea. Prominent on the Tharsis Bulge is the tallest volcano in the solar system, Olympus Mons, accompanied by 3 nearby shield volcanoes. Looking forward, Mars's north pole, Arsia Mons, is the most southern, then Pavinus Mons, and finally, Ascratus Mons. These adjacent volcanoes occur in a chain-like sequence reminiscent of the tectonic plate movement that produced the Hawaiian Islands, which raises the questions of whether geothermal processes are still at work on Mars. And I have a picture of Olympus Mons for you guys. There it is. Beautiful. So you can clearly see, even though this isn't a one of the elevation maps, like the colored elevation maps, you can very clearly see that it it's a volcano. It's a lot taller in the center than the rest of it, which is pretty cool. So yeah, and it's absolutely massive. Yeah, it's Olympus Mons on Mars, yes. Yo, Google, you need to chill out. Aliens are going to steal our data. Oh my god. Amazing. Yeah, that's the biggest volcano in the solar system. Of course. Of course, Charlie. I love reading for you guys. It's a good time. I like it. All right. Moreover, extremophiles may thrive in possible underground water reserves, deep in the crust, or at the Martian polar caps. Researchers have detected methane in the atmosphere, which could suggest active volcanism or a more exciting, possible microbial source. Despite Mars's tenuous atmosphere, images by the Mars Reconnaissance Orbiter indicate groundwater sporadically breaks through the surface to briefly flow down steeply sloped terrain, and data from the 2008 Phoenix lander indicate its soil is similar in acidity to Terran soil. Added to this are recent findings that ancient fossilized life on Earth, dating to more than 3.4 billion years ago, metabolized, and lived on sulfur instead of oxygen, as Earth's atmosphere was not then oxygen rich. All of this suggests that Mars could harbor life deep within its ruddy dirt. If the Mars Science Laboratory's rover Curiosity finds evidence of ancient or extant extremophiles, we might discover how life emerged on the early Earth. The other tremendous appeal of Mars is that it is the only planet astronauts could travel to and explore in the near future. Alluding to the passion with which we dream of stepping foot on worlds beyond our moon, Ray Bradbury has observed, quote, "We know not why we thread an architecture of travel in a fiery path across a winter space and warm far worlds with our breath." End quote. Perhaps we do so simply because we survive on our own relatively cold planet only as a result of technology. Anthropologist Ben Finney points out that we inhabit the globe from pole to pole solely with the aid of our technological ingenuity. Finney contends that the moon or Mars represent a logical next step for human migration. He researched the ocean routes Polynesian peoples navigated via canoe over as much as 1,000 miles of open ocean, from South China and Southeast Asia to Hawaii and other islands, to demonstrate how humans might hopscotch to nearby planets. Finney has shown that Polynesian peoples sailed with all the supplies they needed to establish themselves on islands that they could have only speculated existed, but had never charted or seen. This was an enormous feat without even the aid of a simple compass or sea charts. And yet, they accomplished it using horizon markers and the rising and setting of the sun and stars. The Polynesians succeeded, asserts Finney, precisely because they did not regard the ocean as an alien environment, but one which was utterly natural and essential to the spread of human life. End quote. Even as ancient seafarers ventured far beyond known shores to settle uninhabited islands in the wastes of the Pacific, Finney argues that we could and should strike out across the solar system. The extremely challenging act of humans venturing to Mars or an asteroid could mark the first step. Noted physicist Stephen Hawking would agree. Hawking contends that the future of our species depends on our becoming a truly spacefaring species as a means of surviving natural or human-produced global catastrophes. Archaeologist Peter Cappelletti observes that extreme exploration, quote, begun more than 2 million years ago with a few rough stone tools, and what would become Africa's Olduvai Gorge would culminate in Apollo 11. End quote. Our desire for travel and exploration will take us far beyond Earth, suggests Cappelletti. Quote, by the time a human finally claimed to have stood at the North Pole, that icy coordinate had come to signify, and continues to represent, the human search for something larger in our culture and ourselves, the sense and the knowledge that our journey is a continuous one, and that the geographic firsts we credit to ourselves are merely waypoints on a continuum begun 2 million years ago. If our culture, and increasingly our robots, allow it, this path may continue for millions of years more. We have set human feet upon only one North Pole. In space, there are millions of North Poles waiting to be discovered. End quote. As of this writing, Opportunity continues sampling the Martian terrain, and with each turn of its wheels, we take in more of the landscape, not just in images downloaded to NASA's archives or as attached links to Google Mars, but into the human imagination and into our dreams. As Cappelletti indicates, there are many mountaintop vistas in our solar system yet to be glimpsed, through the stereoscopic eyes of our robot co-explorers and, eventually, through our own eyes. The sublime heights of Martian volcanoes entice the explorer in us. Mountain climbers and space enthusiasts dream of summiting Olympus Mons, rising 69,480 feet above the Martian surface, and imagine the sweeping vistas they would take in from the rim of its calderas, or from the top of nearby Asocrates Mons, reaching 59,699 feet, or Arsia Mons summit of 57,085 feet. Our tallest peaks above sea level pale in comparison, with Mount Everest reaching a mere 29,035 feet. Rock climbers likewise anticipate the grandeur of venturing into Valles Menares, extending more than 2,500 miles in length, and whose canyon walls soar from 3 to 6 miles high. But we don't have to wait for a brave explorer to rappel over 6-mile vertical scarf of Olympus Mons. Robotic eyes are even now taking us there. The journey to and across Mars's cracked and cratered terrain is one of the great travel narratives of the 21st century. With our rovers, we have alighted upon and are monitoring through its fascinating desertscapes. In July 1997, the Pathfinder mission successfully landed the Sojourner rover at Ares Vallis. Project scientist Matthew Golombek commented that, at the time, quote, "An entire generation had never witnessed a landing on another planet," end quote, and reported that within the first month of operation, roughly 566 million people accessed the mission website. The twin mirror rovers captivated even larger audiences. As science studies scholar Robert Markley points out, quote, "Sojourner had traveled a few yards to take readings of the mineral composition of several rocks. The 2004 rovers provided a photographic record that seemingly mimicked the experience of humans walking across a Martian landscape reminiscent of terrestrial deserts." End quote. Markley characterizes Spirit and Opportunity's images as the first vacation photographs from another world that in turn have become part of the semiotics of human visualization. Through these rovers, we've sampled the planet's sedimentary and volcanic rocks, as well as its ubiquitous dust. We've sniffed the air, measured barometric pressure, tasted the soil to determine its alkaline or saline qualities, and bored into rocks, searched for fossilized evidence of water. On balmy afternoons, by Martian standards, we glimpse the simultaneous dance of multiple dust devils. We've witnessed silent sunrises, seen morning fogs cling to the valleys and dissipate, and watched from Husband Hill through Spirit's cameras as the sun sank below the horizon. In winter, the rovers weathered the cold, dim days, and we too waited them out. Rather than our rovers exploring with us, it seems that we've tagged along with them as they traverse, photograph, and engage with this captivating and stark landscape. Humans have a presence on Mars, even if for now it is limited to remote-controlled rovers ambling over its arid plains. Little could Steve Squires know that his sturdy Mir rovers would continue doing science for years beyond their 90-day mission. Squires wonders about the astronauts who might someday find the derelict rovers. Quote, "Above all, I simply hope that someone sees them again," writes Squires. Spirit and Opportunity have become more than just machines to me. The rovers are our surrogates, our robotic precursors, until astronauts someday leave their boot prints in our wheel tracks at Eagle Crater. End quote. Those astronauts are just as likely to find remnant tracks of Mars' Scientific Laboratories rover Curiosity. And Perseverance now. If W.H. Auden was right in his poem Moon Landing about the eventuality, from the first flaked flint of humans walking on the moon, then boot prints on Mars seem equally probable, even inevitable. And that's the end of that chapter. So exciting and esoteric and fun, and I like it. It's not esoteric. We have landers on Mars, but thinking about one day if somebody goes and like they can go walk over and pick up Spirit and be like, "Hey buddy, let's bring you back," stuff like that. That's cool. I saw you guys were chit-chatting about stuff. NASA says Olympus Mons is about the size of Arizona. Yeah, it's pretty big. The base would cover most of the state of Missouri, and the caldera is about the size of New Jersey. Damn, it's massive. It's so big. Yeah, of course. I like finding the images because it just works so much better. I used to take the pictures of the figures, and it worked pretty well for what's the last book we read? I don't even remember. Einstein's Monsters, because a lot of those were just like figures, but a lot of these are like black and white pictures that I'm sure are full color somewhere, and a lot of them are NASA pictures. So I've been trying to find those and keep them because it's nice to look at the full color ones, Um, let's see. What else did you guys say? Another. Oh, there, yeah. That's Mars Reconnaissance Orbiter. I sent the link to the MRO. That's cool. Its height is about 2.5 times. Oh, here's a cool size comparison thing from Student McLeod. Thank you for that. So if you guys have any context of how big France is, I mean, you have the context of it's a country in the world, but this is Olympus Mons over top of the entirety of France, which is crazy. And I guess these are individual features. That's probably the caldera in the center, but it's massive. And yeah, Mount Everest has grown, I believe, which is weird. Here's another Olympus Mons to scale. So this is Olympus Mons, this whole big boy. And then we have Mount Everest here and Mauna Kea, which is just wild. And apparently, I guess that must be high cloud level, because I think clouds can touch Mount Everest. I'm pretty sure. Yeah, Ingenuity as well now. Yes. Let's see. Oh, that's pretty. Here's a picture of a side-lit Olympus Mons, which is really cool. And you can just... Seeing it from the side makes it make a little bit more sense, because I feel like sometimes when you look right down on it, it almost looks like a crater. Like if you compare it to this, my brain kind of wants to say, oh, that must be an indent. You know what I mean? But when you see it from the side, it's a lot clearer that it's definitely a big old volcano. But yeah. So I think that's about it for today. Thank you guys all for joining me and hanging out. This was a fun chapter to read. It was a little bit long, but we got through it in pretty good time. And thank you guys all for hanging out and chatting with me. Let's see, what do we have coming up this week? So on Wednesday, we have a news stream, like for the background music. Yes, I will send that. There's a post stream now. It'll run for like 5 minutes. While that's running, I'll send those links. I don't know how quickly I can find them, but I'll try to find them pretty quick. Because there's a few different songs. But, what was I saying? Oh yeah, so Wednesday we have our news stream. Most of it's going to be talking about Perseverance again, because exciting stuff. We'll probably watch that video that they released that some of you guys said you saw, and just talk about some of the stuff that's coming back from it so far. And then right after that, immediately after that, we're going to have Professor Impey's Q&A stream. So you guys can just come hang out for the early stream, roll right into the next one. It'll be great. And then on Friday, we have Amateur Astronomy. And then next week, book stream, of course, on Monday. But we're going to have an exciting new stream. So if you guys haven't heard, we are going to do a special Q&A stream with Professor Impey on March 2nd. That will, instead of being about the regular, more science-focused astronomy, astrophysics stuff that he normally talks about, we're going to be doing a whole chat about just some of his cool life experiences, what he's done in his career, the places he's been. He's got a lot of really great stories. So that's going to be a semi-regular thing we start doing. And that will be, everyone can watch it, but only subscribers will be able to chat. So if you're interested, you guys can subscribe for that. And yeah, you had a super good time. Yeah, of course. I'm glad you enjoyed it. Thank you for being here. Just curious, what's my role during the Q&As with Professor Impey? Well, on the YouTube ones, I don't really do anything. Matthew manages that whole thing himself. But for the Twitch ones, I run the whole back end. So I run the whole Twitch setup, and I also grab you guys' questions and give them to Matthew so he can ask them. So I'm the one that's we trade off who chats on things, because sometimes Matthew has to throw something in the chat. But I'm usually the one that grabs the stuff and I put it into a little Google Doc that Matthew and I are both on. Alexander often gets a shout out, but not you. Alexander's very helpful too. I think he sets up the YouTube side of it. So he does the YouTube setup and I do the Twitch setup. Alexander's great. He's a cool guy. But yeah, I'm pretty sure Chris usually thanks me. I'm not there on the YouTube ones though. That's why he doesn't thank me there. So if that's what you're wondering. So yeah, I think that's pretty much it. Thank you guys so much again for being here. Remember to subscribe if you can, and if you're interested in that other Q&A that we're going to do next week. And I will see you guys on Wednesday. Bye.